Howdy, geometry. Let's talk about circles. This unit is all about circles, and what we're going to do is we're going to start with the equations of circles and what happens if I graph a circle on a coordinate grid. Now, to do that, though, we're going to start by talking about the distance formula. So it says, what's the length of the segment shown in the coordinate plane? Well, if I want to find the length of that segment, one thing I can do is draw in a right triangle and use Pythagorean theorem. That's 3 units long. That's 4 units long. So a squared plus b squared equals c squared. Let's see, that's 9 plus 16, which is 25, equals c squared. I square root both sides, and the square root of 25 is 5. Okay, so that length is 5. What have I learned from that? I've learned that, just a reminder, you can find the distance between 2 points on a grid by doing a squared plus b squared equals c squared. And I've also learned that if you go over 4 and up 3, or even over 3 and up 4, you can get a length of 5, which is pretty cool. So if we come down here and it says graph all the points whose distance from the origin is 5 units, what kind of shape is this? Okay. Can you find 8 points? What could the equation of the shape be? All right, well, let's see. If I want the distance from the origin, that's right here, to be 5 units, I could go up 1, 2, 3, 4, 5. That's 5 units away. Down 1, 2, 3, 4, 5. That's 5 units away. 1, 2, 3, 4, 5. That's 5 units away. 1, 2, 3, 4, 5. That's 5 units away. So I found 4 points. What kind of shape did I make? Well, if I were to connect those, I could kind of see a square. But it said I should be able to find 8 points. Oh, yeah. We just said you could go over 4 up 3 or over 3 up 4 and also get a length of 5. So I'm going to do that. Over 4 up 3. There is a point that's 5 units away. Over 4 up 3. Or I could do over 4 down 3. That'd work too. And now I have the 8 points. All right, I'm starting to see something. You know what? I'm going to go one step further. Let's find 12 points. A 3 by 4 triangle would work. So what if I went left 3, up 4? That would be a 3 by 4 right triangle. That should still have a length of 5. So right 3, up 4, down 4, down 4. Oh, I see it. That's a circle. The locus of points, fancy math word, the locus of points that are a certain distance from a given point will always make a circle. What could the equation of this shape be? Well, if I want things that are 5 units away, I want to go over X amount. I want to go up Y amount. And I want the hypotenuse to be 5. So what I really want is a Pythagorean theorem where a squared plus b squared equals c squared, but I want c to always be 5. So I want to go over left or right an amount of x. I want to go up or down an amount of y. And then that would mean that a squared plus b squared equals c squared. And I get a circle. And that, my friends, is how you get the equation of a circle. Okay, so why is that interesting? Well, you've seen other equations before. You've seen like y equals mx plus b. That makes a line. You've also seen y minus y1 equals mx minus x1. That's another line, but it's kind of like a line centered at the point x1, y1 with a slope of m. And you've also seen y equals ax squared plus bx plus c. And that, if you remember, that makes a parabola. That makes one of these. Well, now we have a new one. We have x squared plus y squared equals a number squared, and that's going to make a circle. So now we have a rule. If you want to make a circle whose center is the origin, the equation of that circle is x squared plus y squared equals r squared, where r is the radius. But not all circles have a center at the origin. So if we use transformation rules, if you remember those a little bit from algebra, if we use transformation rules and I want to shift that center to the point HK, the equation of the circle is x minus h squared, y minus k squared equals r squared. And what I often tell my students is if you want to write the equation of a circle, it's something squared plus something squared equals r squared, where you negate the center and you square everything. Negate the center, square everything. Okay. So now we're just going to do a whole bunch of repetitions so you see what's going on. What's the equation of a circle centered at the origin with a radius of 9? Well, if I'm centered at the origin, it's x squared plus y squared equals r squared. My radius is 9, so it would be 9 squared. X squared plus y squared equals 9 squared. And normally what we do is we actually square that last number. So 9 squared is 81. X squared plus y squared is 81. What's the center and the radius of this circle? Okay, well that says x squared plus y squared, so I know my center is the origin. Put an extra I in there for no reason at all. Okay. And then 16 is r squared. So what squared is 16? Oh, 4. So my center is the origin, and my radius is 4. All right, let's look at another circle whose center isn't the origin. Shown below is a circle with a center of 2, 3, and a radius of 5. All right, so if my center isn't the origin, instead of x squared plus y squared, I have x minus h squared plus y minus k squared. You negate the center. So it would be x minus 2 squared, y minus 3 squared equals 5 squared, which we really would write as x minus 2 squared, y minus 3 squared equals 25. Okay. Name a point in the first quadrant that's on the circle. Well, let's see. The first quadrant is this one. Let's find a nice point that's on the circle. How about, let's use this one right here. That's the point 5, 7. Prove that that point is on the circle using the equation. Well, if you want to prove that a point is part of a line or a parabola or a circle equation, all you're going to do is put 5 in for x and 7 in for y and see if the equation still works. So I start with x minus 2 squared plus y minus 3 squared is 25. That's the whole circle. And I want to know if 5, 7 makes this equal 25. Well, 5 minus 2 is 3, so that's 3 squared. 7 minus 3 is 4, that's 4 squared. And let's see, 3 squared is 9, 4 squared is 16. Yeah, 9 plus 16 does equal 25. Woohoo! All right, example 5. What is the radius and the center of the circle given by this equation? All right, so you negate the center and square everything, which means since I see a plus 12 here, I know my center is negative 12. I see a minus 4 there, so my center has a positive 4 for its y coordinate. So whatever is in the parentheses for your center, you negate it. So my center is negative 12, 4. And then my radius is just the square root of that last number, which is 81. I apologize for the awful carriage return there. Okay. And the square root of 81, oh, wait a minute, that's a 9. Cool. And then it says identify 3 points on the circle. Okay. So if I want to find 3 points on the circle, you know what? I'm going to think about the graph. So if I were to graph this, I would have to go to negative 12, 4. All right, negative 12, 4. And then I would need to plot my center, which would be here. And then I need to go right 9, left 9, up 9, down 9? Well, let's do that. So if I went from negative 12, 4, and I went up 9, that would be the point negative 12, 13. I added 9 to y. But what if I went down 9? What if I subtracted 9 from y? Then I'd be at negative 12, negative 5. Well, what if instead I went right 9? Well, if I went right 9, I'd be adding 9 to x. So that'd be the point 3, 4. And if I went left 9, I'd be subtracting 9 from x. Negative 12 minus 9 is negative 21, 4. Okay. And then, last but not least, what is the center and radius of the circle given by this equation? X squared plus y minus 3 squared equals, I didn't want this to say 81. Do me a favor, scribble that out and make it say 15. That's what I wanted it to say. Okay, so I want the center. Well, the x doesn't have a parenthesis with it. That's okay. When it was x squared plus y squared equals r squared, my center was the origin, which is 0, 0. So if you ever see your x or a y without a parenthesis, that means that coordinate of the center is just a 0. And then it says y plus 3, so negative 3 is my y coordinate. And then my radius is that r squared equals 15, so my radius is just the square root of 15. And that doesn't simplify, so I leave it alone. Sometimes your radius isn't a whole number. That's okay. A radius of the square root of 15 is like, I don't know, 3.9-ish. So that's just a center at 0, negative 3 with a radius of close to 4. Okay. So to get your center, you negate what's in the parentheses. To get your radius, you square root the number at the end. So you have learned 2 things today. If you want to create the equation of a circle, if you're centered at the origin, it's x squared plus y squared equals r squared. If you're not centered at the origin, you negate the center and make x minus h squared plus y minus k squared equals r squared. And then if you want to go backwards, you negate to find your center and square root to find your radius. Now that you understand that, try the practice problems where it says problem set exercises. And those start on page 4 and only page 4. Have a good one, everybody.